so let's look at these for both types. So we're going to do scaffolding. Again, don't make a square root sign, make a division sign. The first number goes in the house, and the other one goes outside of it. All right. And so with scaffolding, I mean, you keep the numbers as is. There is no moving the decimal point. You just look. And so I have 325 thousandths. I have 455 thousandths. I know it can go in there once. So I'm going to go ahead and subtract. So 0, 3, 1. All right. Now at this point, I know I can't do 1. And so some of you thought it was helpful in class, like if 1 goes with, what, 0.325, then 0.1 would be 10%, which would be 0.0325. And some of you thought that was helpful. All right. So I might do 0.1, which is minus 0.0325. I'm going to add a 0 there. All right. And again, I might have to ungroup. So this is a 5, a 7. What was that? So this would have to be a 0 and a 12, 9, 0. Okay. And then maybe I'm like, ooh, I could do 2 of them. So 0.2, that would be 2 of these, which would be what, 0.06 and then 5, 0 if I double that. Okay, so then if I subtract, and then it looks like, ooh, I can do exactly 1 of them. And I have 0 left over. So my answer is 1.4. So if I divide 455 thousandths by 325 thousandths, it goes in there 1 full time and then 4 tenths, so 1.4. Now, if you do the standard algorithm with that, is I would have, again, the first number goes in the house here, second number goes here. This is kind of more of a, this is our answer, how many groups idea, so, or how many in a group. So you want to move the decimal out here so you have a whole number of groups. So I'm going to move this 3 jumps and 3 jumps. So I'm really basically scaling them both up. So if I write it in fraction form, I have this divided by this, and I'm going to scale them up by 1,000. And so I'm compensating. I mean, I'm just multiplying by 1. It's like I'm getting a common denominator. So it's still equivalent. I don't have to do anything else. Like I multiplied this by 1,000 and this, and so that's balanced. So my answer is my answer. I can see that that goes in there once, so I'm going to subtract. And I need to add a decimal and bring down a 0. All right, and so again, the nice thing about scaffolding is you can do whatever you want. Here you got to figure out whatever's closest, and of course we know it's 4, but if we don't know it was 4, we might test it out and see that it's 4. All right, and then again, the decimal goes straight up because this is your ones position and this has to be your tenth, so the decimal has to go there. All right, let's look at this one. Oh, and by the way, it should make sense that the answer is bigger than 1 because you're taking a larger number divided by a smaller, so it has to go in there more than 1 time, okay? Now, here we're taking a smaller divided by a larger, so I know it's not even going to go in there 1 time. Like, it's going to be a decimal amount, okay, without a 1 point anything, because, again, I have a small thing being divided into pieces that are even smaller. So, first number goes in the house, and second number goes out here. And again, if you haven't done this, why don't you pause it now and go ahead and do this, and then we'll talk about it. All right, so hopefully you paused and tried it or did it before you even logged on to watch. Okay, so again, we made this chart earlier that kind of helped some people. So like 1, if I multiply it by 1, I'm going to get 1.4. If I multiply it by, now again, this is where halves you might be able to do in your head. Like if you think of half of 1, kind of like when we made ratio tables, half of 1 would be 70 cents. So that would work. If that doesn't make sense to you, you could just always move the decimals. So if I do 10%, I move it once. So that would be 0.14. So it just depends on whether you're comfortable saying, ooh, well, half of it would be 70 cents then, because half of 1.4 or $1.40, 70 cents. But if not, you might not use that. So I'm going to use 0.5, but if not, that's okay, because you could always use the other stuff. So like, for example, then I'm going to be like, okay, well, now I need to use my 0.1. Daphne, just wait, Mama's busy. All right, and so when I subtract, I have 0, 3, 5. All right, and then at this point, even this is too big, right? This is like 14 cents. This is like 3.5 pennies. So now I'm going to move my decimal again. So again, 10% you move it once, and now I'm going to move it again. So I'm going to move my decimal in this guy 1 over again. Or if you go back to the beginning, if I move this one over 2, I got to move that one over 2. And again, as a kid, I might just do one of those. All right, and then I might be like, oh, I think I can do another one of those. All right, and then, oh, Daphne, her neck is around a cord. That's not good. Okay, so then at this point, I'm kind of like, it depends on what you recognize. If you recognize that 0.007 is half of this, then you could take half of this, which half a penny would be 0.005. If not, you're maybe probably just going to go, like if you don't recognize the half things, you're just going to, again, move the decimal another place. So 0.0014. So you just move it once, move it twice, move it 3 times. So I know that I could do one of those. I'm going to put a 0 under behind there so I have all my place values lined up. All right, and again, you could ungroup, or if you see that that's 56, is that right? 66 maybe? But you could ungroup, it looks like 56. All right, and then I might be like, oh, well, you know, I could do 4 of those to get 56, or maybe you just do 2. Like as a kid, you might be like, well, I can do 2 of them, which would be 0.0028. So maybe if I do it like a kid did, and then they could be like, oh, I could do that again and use it all up. So again, some of you indicate that maybe making some type of chart with place values might be helpful. All right, so what's my answer? I have 0.6 in the tenths position. What about hundreds? I have 1, 2 in the hundreds position, and I have what? 1, 2, 3, 4, 5 in the thousands. And so that is my answer, okay? Now, if I do long division, all right, let me look at that. Again, first number goes in the house. So 0.875 divided by 1.4. And again, this is kind of like how many in a group. So I want to get 14 groups. I don't care what I'm divvying out. I just want to make sure I have a whole amount of groups. So I only care about this number. So I'm going to move this once and this once. I don't care if this is a decimal. And again, what you're really doing there is you're kind of dividing it among 1.4 groups. So if you multiply both by 10, then you get $8.75 divided by 14 groups. That makes a little more sense. So we only care about this number. All right, so I moved the decimal, so now my decimal's there. 14 doesn't go in 8. 14 goes into 87. Again, if you don't know, you might take 14 times 5 and get 70, and you're like, might be like, can I do higher? And then you might be like, oh, 84, I can do 6. So it might not be that that's immediate, all right? You might have to play around to find the biggest possibility. Subtract, you get 35. Okay, again, some of you might be like, oh, maybe it's 3, or a kid might be it's 3, but that's too big, right? So then you might be like, oh, I can do 2 and get 28. So I'm going to put 28 and get 7, and then I'm going to bring down my 0. And again, you might recognize that's 5, you might not, or you might have done it earlier in your quest to find an answer. And again, your decimal goes straight up because you scaled them both by 10, so the decimal's in the appropriate place value. So that was how you do long division on that. All right, I think I hit all of them, so hopefully that helps, and that gives you a strategy to move forward. Take care. Bye-bye.